Okay, so our next speaker is Brandon Taylor, and he's going to be talking about LightQuery.jl.
Good morning, Baltimore. Thanks for letting me live out my Broadway fantasy for a minute. Programmers. Okay, I'm presenting a query package I wrote. There's other query packages out there, and mine is new, so I'm mostly hoping you guys will try it out, see what you think, and contribute if you like it, and if not, tell me why, and I'll see what I can do. So like I said, I haven't really finalized the API, and I'm also very finicky. I tend to write and rewrite things. But it's got some solutions to some really big problems that plague query packages in Julia that I'll talk about. And I also think it's fairly fully featured in terms of doing all the things you would want a query package to do. It's a little bit low level right now, but we can, of course, build on top of that. So I came to Julia from R 5 years ago as a research assistant, kind of sick of R. At that time, I was addicted to dplyr, which is a package in R that some of you may have used or not. And I really wanted to do something dplyr in Julia, and kind of got frustrated immediately that there wasn't something like it. So I've just, as a hobbyist, I've been working on this for the past few years to fill out the query universe in Julia. I'm an economist by training, in fact, kind of a socialist heterodox economist. So it's kind of a weird hobby of mine. I think the real reason I'm interested in programming is just because as an outlet for anxiety, because I see so much, I write about all these problems in the world. But maybe a nicer answer is that I'm interested in making economics more open and transparent and participatory, and I'm hoping that Julia can contribute to that in some way. So I'll go through some of the design decisions and also just some programming thoughts that I had that may be helpful to you or not. You can choose to disregard my advice. So the biggest problem is kind of something obscure that not a lot of people have heard about. It's an F expression. It's something that R can do. So in R, when you pass an expression, it comes bundled together with the environment that the expression was created in. So you can access all of the variables in that environment in a nested way, and you can change it and manipulate it, right? And this is something that's impossible to do in Julia. In fact, purposely impossible because it's very slow. So for example, in this little code snippet from R, you make a data frame with two objects in it, A and B, and then we have this global variable C. And then in this statement here with X, A plus C, what we're doing is for A and C, we're searching for X for A, and we find it, and that's great. And then when we search X for C, we don't find it. So then afterwards, we start searching the environment that the expression was created in, and we find that C is 3, right? The solution to this impossibility problem is really anonymous functions. They make things a little bit more verbose, but I think it's maybe worth the sacrifice for the speed, or hopefully, fingers crossed. Otherwise, people won't use Julia. But, so basically, you can use underscores to make anonymous functions. There's a pull request in base for using underscores in anonymous functions that a lot of people have been talking about for a long time. But in the meantime, I provide an underscore macro that you can use to create anonymous functions with. Okay, and then the second thing is chaining. So querying, I think, is chaining almost by definition, right? That's something almost inherent to the idea of querying. So the way that LightQuery is set up is that you have these two macros that work together. I have this chaining macro, at less than, which starts the chain, And then inside each of these query calls, we have little anonymous functions that pass data transformations and whatnot. They work together really pretty well. The usual problem with macros is that, or one problem with macros is that they resolve outside in. But in this case, really, I really want the macros to resolve inside out. We need to know the underscore inside one of these dots that it's tied to, you know, the smallest macro containing it. So yeah, I've set those up to work together well. So this is because we're talking about macros, I thought I'd start with I'd add a tip. So this is something I learned from looking at other people's code, and it's something that they won't tell you to do in Julia because they've worked so hard on a sanitizer. But I do all of my own sanitizing, so I just escape the whole macro. It's easier for me because you can have all your macros really just be functions, and the functions nest very well, and you don't have to worry about, you know, which arguments need to be escaped and where to put your escapes. But you also, of course, need to be careful about when to use a gensim and when to not. And then the second tip I had for writing macros is, this is something that bothers me in other people's packages, is missing line numbers. So when you write a macro that creates lines of code, you always need a line number before every line of code. And the easiest way to solve that is just to use this double underscore source. It will work in any macro, and you can just use that to fill in the line number for every new line of code that you're writing. Okay, so here's another Julia problem. It's Covariance Star. In fact, I don't really quite understand what covariance means, but I'll explain the problem with an example. So I have this vector of two objects, and the question is, what is the L type? When you run this in Julia, it's a union of pairs, which seems reasonable, right? But there's a problem, is that you get kind of this combinatorial explosion of types. You know, if you have, instead of a pair, you have a 6-length tuple, and each item in the tuple has 2 possible types it could be, then the type of the tuple, you know, is 2 to the 6. There's 2 to the 6 possibilities for the type of the tuple, and it creates havoc. And so really what you want in this kind of situation is a pair of unions. To get that kind of optimization, you really need to use plain tuples in Julia. And I think it's because tuples are covariant, but I'm not 100% sure. So when I was working on LightQuery, I kind of had to redesign NameTuples from the bottom up to make sure that they were covariant. So I have type names, and a name tuple is just a nested tuple where the first item is a typed name. And then I have this macro so that you can use a regular names tuple syntax and get the LightQuery version of a name tuple. Right, and here's another problem, that tables are kind of pathological. So the rows tend to be short and have many different types in them. And columns are long, and they tend to have, just 2 types, union of missing and something else. And it requires really 2 different programming strategies. So the first programming strategy for rows is to use recursion. So here's an example of recursion. This is just kind of pseudocode. Recursion is nice because inlining will figure out all the types for you. But there's a problem that constant propagation is disabled by recursion. So if you're trying to use recursion and constant propagation, you need to wrap all your constants in a type. So in LightQuery, the column names are typed, and another example is I have typed bools in another package I wrote called Julian arrays. And then another problem with recursion is that Small unions don't really work well as captures when you create anonymous functions. This may or may not get fixed in Julia, but in the meantime, when you're doing recursion, you need to really make sure that captures are passed as arguments that get passed along the line as you recur into each new step. Okay, and then the strategy you want to use for columns is just make iterators. Columns are just so long, and you don't really want to have to allocate for each step. So the query operators really should all be iterators. This has, the side effect that everything needs to be pre-sorted for when you use it in LightQuery. So I have this example here of this vector, which is 3 symbols of A and 2 symbols of B. And instead of allocating, 2 vectors, one which has the positions of the A's and one which has the positions of the B's, the way I do in LightQuery is I have an iterator that will first return, 1 to 3, and then 4 to 5 the next time you iterate, and then you don't get any allocation. The problem, though, is that as you're iterating through an iterator, you need to be able to use the iteration states back as indices. So to index, that A is in the first 3 positions and B is in the second, the 4th and 5th position. And in general, iterators aren't very indexable in base. So I have a dedicated index type for doing that. That's unexported at the moment, but maybe be exported at some point. All right, here's another problem, row-wise collections. So row types are often really complex. So here's the type you might see for a row. This is just a row with 2 names, 2 variables. One is A and one is B. And A could be missing or int, and B could be missing or float. And it can be collected efficiently for reasons that are kind of above my pay grade. But given that that's kind of a barrier, collection really should happen column-wise. So the way collection happens in LightQuery is that each cell gets synced into a separate column. As you collect, the columns all will have simple element types, like a union of missing and init. And after you're done collecting collecting all these columns, if you want to view them as rows, it's pretty easy to do. You just got a zip, and then there you go. Problem solved. This turns out to be really tricky. It's kind of a similar problem to unzipping, which is not implemented in base because it's very tricky. But here's kind of the way it needs to get done. The issue is in Julia, since Julia is dynamic, you don't have return types, so you can't figure out ahead of time how many columns there's going to be, or what the names of the columns are going to be, or what the types are going to be. You just have to figure that out as you iterate, right? So in this example, the first item is A is 1 and B is missing, so we create an int column for A and a missing column for B, and then in the second iteration, we widen the types so that the type of column A is widened to be union of missing and int, and the type of column of B is widened to be a union of float and missing, and then we add a new column for C, which is a string column. So what's the future for querying? It'd be nice if we could figure out an answer for using underscores as a syntax to create anonymous functions. The issue then is, where is the boundary of that function? It's not immediately obvious where it should be, or so in the meantime, I have a macro for doing it. So another thing that would be nice is NameTuple covariance or whatever is creating this ability to handle many items of many types. And then, some sort of story for indexing iterators, maybe inheritable traits. So like an iterator would inherit the traits of its parent, and if the parent's indexable, then the iterator is also indexable. Okay, so that is the end of my presentation. And then the next part I wanted to work through, how long has that been there? Is just the LightQuery tutorial, because I worked really hard on it, and I think it might show off some of the nice features that the package has. So the first thing I want to do is I'm just going to rename this file to be a Julia Markdown language, Julia Markdown document, and there's been this recent upgrade, so now that the syntax is highlighted correctly, and I can just run this code as is without needing to change anything, which is nice. And then I'm going to check the working directory just to see where we are. But I think we should be. All right, so I'm going to get to the. Sorry, hold on. CD. Oh, sorry. Julia. You feel free to follow along at home. So now I've changed the working directory to be the test folder for the LightQuery package. So first I'm going to use the package. And for the tutorial, I'm using dates and some other packages. So I have some tools that I'm using from dates and some tools that I'm using from time zones and some units. So I based this tutorial on the dplyr tutorial. Thank you, Hadley Wickham. I created the data using our code, in fact, and saved it in the test directory of LightQuery. And as I was working through his tutorial, I realized that the data is really messy, and because of that obsessive anxiety I talked about earlier, I ended up spending most of the time just cleaning up the data and realized that it was a valuable teaching exercise. So I'm just going to work through some data cleaning steps. So the first thing I'm going to do is bring in airports as a CSV file. So while that's good. So CSV, the package, has very strict requirements for indexing in a type stable way. You need to know the type of each column ahead of time and the position of each column ahead of time, which is not something that LightQuery requires. Anyway, so I've created this mechanism to convert a schema into using this row info function, using a table schema to convert it to this a type here, which I'm calling, which will have the position, the type, and the name of each of the columns in the table, and you can use it as a type stable selector function. So we're going to get the first row of the airports file, and then I'm going to run the airport on it to turn it into my version of a name tuple. And the next step, I'm just going to rename so we know what the variables mean. I don't know if I'm pretty obsessive about never using abbreviations when I code because I think it's important for people to be able to read what I'm doing. So I've renamed altitude to altitude and daylight savings time and et cetera. So you can see in the names what all these columns actually mean. And then I'm going to remove some redundant data. That's data that we can already figure out from the time zone. And then I'm going to add some units. So I'm going to add a feet to altitude and degrees to longitude and latitude. The next step, I'm going to use the time zone package to create a time zone. So this looks tricky, but it's not that bad. In the airport's data, there's two different kinds of time zones. There's standard time zones and legacy time zones. So I have to tell time zones it could be either one of those. The second thing is that some of the data is missing. So I have this function called ifKnown, which will, if it encounters missing, will break and return missing instead of continuing on with the function. And finally, I have a type annotation because it doesn't seem like time zone is type stable without it. But I guess that's not strictly necessary. So now we can get the time zone of our first airport. And we can see it's New York, which is UTC 5, I guess, or 4, depending on where you are in the year. So if we put that all together into a function, and now we can run it on the first row of the airports file, and we get, nice clean data with units and the true time zone, which is nice. And now if I run that over each row, this happens lazily, so this doesn't allocate. We can see the first result from that. And now I'm coming to the point where I need to collect. So I'm calling make columns, which is going to collect the data into columns, and then afterwards to rows so that we can view it as rows. Because I just want to see the first couple of rows. And to do that, I have this peek function, which gives us a nicely formatted markdown table, which is here. How am I doing on time? I guess I only have 3 more minutes. No? How many more minutes do I have? How many? Yeah, around 10 minutes. Okay. All right. I just want to make sure to stop in time for questions. But you can finish this by yourself. Next, I'm going to index the airports by their airport code. So now we can, look up JFK really fast and see all this information about the JFK airport. So that was cleaning the airports. And the next step, I'm going to clean the flights data with kind of the same steps. I'm going to get the CSV file. I'm going to create a converter object. I'm going to rename, remove, and then add some units. Then I am going to get I'm going to figure out what the airport corresponding to that flight is based off of its origin. So we can see that the first flight was out of the time zone that's New York, America, New York. I'm going to split up some of the times. So 5:15, it gets read in as 515 instead of 5:15 the time. So I use divrem to split it up into 5 minutes and 15 seconds. And then I'm going to put that all together into a zone to date time. So here we have a date time with a time zone attached to it. And now I have putting that into a function. And now we can get the zone date time for the origin of the flight. So the flight left at this time in this time zone. And for the arrival, so it arrived at this time in this time zone. So now we can put that all together. I have this get flight function. And I'm going to run it over all the rows in the airports. And I'm going to collect again by collecting into columns and then viewing as rows. Why didn't that work? It takes a minute. It's a pretty long data set. And I think I've worked really hard to make sure that everything's very type stable, but I'm guessing there's probably a lot of compilation time that's involved. You can peek at the first couple of rows, which you can see here. We've got the origin and the destination of the flight and the tail number. Okay, so the next thing, since we have 5 minutes left, I'll stop this and take some questions. But the next section is on grouping and reshaping and joining. So anyway.
Any questions?
If there's not questions, I can keep going.
I have a question. What is your experience with light queries of this, what you have shown at the very end? So the balance between type stability and compilation time. Of course, for really big data sets, it's pretty clear where the balance is, but like for the normal size data sets like 10,000 rows or 100,000 rows, how do you think you find this balance in practice?
I don't know, and I'm also kind of going to punt the ball downfield to base Julia to figure out compilation times. I don't really view that as part of my responsibility. I don't. Is that cruel or mean or I don't know.
No, but because my question is, do I understand correctly that actually, because of type stability, each time you call your functions, you have to specialize them and combine them?
If you get a new combinations of types, every time you get a new combination of types, I believe that there is a compilation that's done. Yeah. So, although I haven't looked into it in detail, so maybe not.
Okay, so let's thank Brandon.